So how do you explain this? Well, some people say, well, all these universes with different values of these constants all coexist. It's just we only see the one that we're in because the numbers come out right for us.
Not an anomaly, not a glitch, a pattern. Repeating, circular, etched into the afterglow of the Big Bang itself. His conclusion? That light is a message. And it wasn't sent from our universe. Here's what you need to understand before we go any further. The James Webb Space Telescope was not supposed to break cosmology. It was supposed to confirm it, fill in the fine details of a story we thought we already knew. The Big Bang fires, the universe expands. Slowly, over hundreds of millions of years, gas collapses into the first dim stars. Those stars gather into small, fragile galaxies. Those galaxies grow. Ordered, gradual, predictable. Webb pointed into the deepest, oldest regions of space, and the universe sent back something that doesn't fit that story at all. Massive galaxies, fully formed, blazing with light, existing at a moment in cosmic history when, according to every model we have, the raw ingredients to build them hadn't even had time to assemble. Astronomers started calling them universe breakers. That name wasn't chosen lightly. But the impossible galaxies are only the beginning of the problem. Because while Webb was dismantling our understanding of how the early universe looked, it was simultaneously confirming a different crisis, one that had been quietly building for years. For decades, cosmologists have used something called the Hubble constant to measure how fast the universe is expanding. The theoretical prediction? Around 67 kilometers per second per megaparsec. Clean, elegant, derived from first principles. The problem is that every time astronomers measure the expansion rate using real observations, supernovae, variable stars, gravitational lensing, red giants, they get a different number. Around 73, consistently, persistently. With Webb's latest data, even more pronounced than before. This isn't a rounding error. This is a 9% gap between what the universe is supposed to be doing and what it is actually doing. And nobody can explain it. Some researchers are now asking a question that would have been laughed out of a conference room 20 years ago. What if our universe isn't isolated? What if something outside it is pulling? We'll come back to that, because first we need to talk about the galaxy that broke reionization. 330 million years after the Big Bang. The universe at that moment is not a pleasant place. It's dark, thick with neutral hydrogen gas, a cosmic fog so dense that ultraviolet light cannot travel through it. Light doesn't escape. It gets absorbed, scattered, swallowed by the hydrogen curtain. The universe is essentially opaque. According to every model we have, this fog doesn't clear until much later. The first galaxies are small, isolated, carving out tiny glowing bubbles in the darkness. Beyond those pockets, nothing. Blackness. Silence. Then Webb found JADES-GS-Z11, a galaxy, burning with ultraviolet radiation, shining clearly and powerfully from only 330 million years after the Big Bang. Not a faint smudge, not a tentative signal, a clear detection of Lyman alpha radiation, the distinctive fingerprint of energized hydrogen, at a moment in cosmic history when that radiation should have been completely blocked. The lead researcher, astronomer Joris Wittstock from Cambridge, didn't try to hide his disbelief. The result, he said, was entirely unexpected. His colleague, Kevin Heinlein, was even more direct. They shouldn't have found a galaxy like this at all. And yet, there it was. When they mapped what this galaxy had done to its surroundings, the scale became even harder to process. It had carved a bubble of ionized, cleared gas stretching 650,000 light-years in every direction. It had punched a hole through the cosmic fog at a time when physics said that hole couldn't exist yet, which means one of two things. Either reionization, the process by which the universe's hydrogen fog was gradually cleared, began far earlier than we believed, or it happened far faster. Both options require us to rewrite the timeline of how the universe became transparent to light. And buried inside that discovery is another question that nobody has answered yet. What was powering this galaxy? Was it an extraordinary population of massive, ultra-hot stars burning through fuel at impossible rates? Or was there something darker at its center? A black hole? Feeding and radiating, doing the work of 1,000 ordinary galaxies? We don't know. And that not knowing matters. This is where Sir Roger Penrose enters the story. Penrose is not a fringe theorist. He is one of the most decorated mathematical physicists alive, a Nobel laureate, a collaborator of Stephen Hawking, the man who mathematically proved that black holes must form from collapsing matter. When Roger Penrose makes a claim about cosmology, the scientific community listens, especially when, the claim is this: the Big Bang was not the beginning, it was a handoff. Here is what his theory proposes. The universe expands, galaxies drift apart, stars burn out. Over incomprehensible timescales, even black holes eventually evaporate, radiating away their mass as Hawking radiation, the slow quantum process that Hawking himself predicted in the 1970s. Eventually, all matter decays. What remains is pure energy, massless photons in an endless expanding void. And here is the twist that makes this theory extraordinary. At that point, Penrose argues, the universe loses the ability to measure time or distance. Without mass, there is no clock. Without a clock, the concept of scale becomes meaningless. And a universe with no meaningful scale, infinite and cold and empty, becomes mathematically identical to a universe at the moment of a Big Bang. One becomes the other. The infinite far future of a dying universe is the explosive birth of the next one. Not a collapse, not a bounce, a conformal rescaling, the end folding seamlessly into a new beginning. He calls each iteration an eon. We are living inside one. There was one before us, there will be one after. This would be a beautiful but unfalsifiable idea. Except Penrose claims he's already found the fingerprints. They're hiding in the cosmic microwave background. The CMB is the oldest light in the observable universe. Radiation released roughly 380,000 years after the Big Bang, now stretched and cooled to microwave frequencies, still echoing across the sky in every direction. It is the closest thing we have to a photograph of the infant universe. And in that photograph, Penrose found circles. Faint, anomalous, repeating rings. Subtle variations in temperature that stand out against the background noise of the CMB. They show up in data from the Planck satellite. They show up in data from the WMAP satellite. Independently, in two separate instruments measuring the same ancient light. His interpretation? These are Hawking points, the dying echoes of supermassive black holes from the previous eon, black holes that evaporated at the end of a universe that no longer exists, their final photons carrying forward into ours, imprinting as these circular patterns in the oldest light we can see, the ghost of a universe that died before our Big Bang. Right there in the data, roughly the angular size of a full moon spread across the sky. Not everyone accepts this interpretation. Many cosmologists argue the circles are statistical noise, patterns that human pattern recognition finds meaningful in what is actually random variation. The debate is ongoing and fierce. But Penrose has heard this kind of skepticism before. Black holes, he points out, were once dismissed as mathematical absurdities, artifacts of equations that couldn't possibly correspond to anything real. We now photograph them directly. We detect their collisions in the form of gravitational waves rippling through space-time. The radical idea of one generation becomes the textbook of the next. Now back to the Hubble tension. The 9% gap between predicted and observed expansion rates. Some researchers, working independently of Penrose, have begun developing mathematical models of something called multiverse interaction, the possibility that our universe is not sealed off from other regions of a larger cosmic structure, that during the inflationary period immediately after the Big Bang, our universe may have merged with or expanded within a broader parent structure. When these models calculate what the expansion rate should look like under those conditions, the number they get aligns far more closely with what Webb and other telescopes actually observe, better than the standard model manages. This is not proof. These models are early and speculative. But the fact that a multiverse interaction scenario fits the data better than our current best theory is precisely the kind of anomaly that in science tends to matter. Webb is finding impossible galaxies. Webb is confirming the Hubble tension. Webb found a galaxy that cleared a 650,000 light-year hole in the cosmic fog, at a moment when the fog shouldn't have been clearable. And Penrose is sitting on what he believes is evidence, real, observable, satellite-confirmed evidence, that something existed before the Big Bang. Each of these data points arrived separately. Each one was unsettling on its own. Together, they are pointing in a direction that cosmology is not yet fully prepared to follow. Here is where we have to be honest about what we know and what we don't. The Big Bang happened. The evidence for it is not in question. What Webb is challenging, what the Hubble tension is challenging, what Penrose's Hawking points are challenging, is the story of what came before, what happened immediately after, and whether our universe is the only chapter in a much longer book. Science is not broken. Science is doing exactly what science is supposed to do, following evidence into uncomfortable places, refusing to look away when the data conflicts with the theory, asking harder questions when the easy ones stop working. The universe is not playing by the rules we wrote for it, and there are now serious, credentialed, Nobel-level scientists who believe the reason is simple. We don't yet know what the rules actually are. We are not at the end of cosmology. We are at the moment just before a revolution, standing at the edge of an understanding so much larger than what we currently have that we can barely see its outline. And Webb is the instrument that's making us look. If this reshaped how you think about the universe, even slightly, hit subscribe because we go deeper every single week. And leave a comment. Do you think Penrose is onto something real? Or are the Hawking points just patterns we want to see in the noise? The most interesting thing about that question is that we genuinely don't know the answer yet.